last topic for today's breakout session is Zero Trust Framework for Remote Access. We are fortunate to learn about this topic from the CEO of Everest-IMS Technologies, Mr. Satish Kumar. He is an industry veteran with domestic and international experience in operations, P&L, and multi-channel product distribution. He takes keen interest in molding Everest Suite, which includes leading security solution. Please welcome Everest-IMS Technologies CEO, Mr. Satish Kumar.
Everest-IMS Technologies is an award-winning software product company. It lays the foundation of digital transformation for enterprises and telecoms. We put the cloud, AI and IoT to work for you in powerful new ways. We cater to large enterprises, telecoms, BFSI, government and other verticals. Our solutions are delivered under the Infraon product suite. These comprise the Infraon ITOM suite, an AI and AIOps-powered overlay system on the ITOM suite, a Zero Trust system, Infraon Secura, and a telecom suite. We also have a Pink Elephant certification for our Infraon Desk product. We have a noteworthy global presence.
Good morning. My name is Satish Kumar. I am the CEO and founder of Everest-IMS Technologies. Today, I would be presenting you on the topic of Zero Trust Framework, especially on its major use case of remote access. Everest-IMS Technologies is a tech startup running out of Bangalore, with its presence currently in Southeast Asia, Middle East, and also a few places in the US. We are a product company which we are specially concentrating in the infrastructure and operation space, and also a lot of products in the security space by itself. We have a product called Secura, which specifically on the Zero Trust framework. In our portfolio, we have multiple products, starting from ITOM, which is an IT operations management. We have products in ITSM, which is IT service management. We have a lot of telecom products which concentrate on telecom management, especially with our OSS set of products. And in the security side, we have a Zero Trust products as the product, as well as a log management system to do heavy amount of compliances. Starting on what Zero Trust is and why is Zero Trust become a major factor nowadays, I would also dive a bit into how Zero Trust is actually implemented in a lot of places, right? Zero Trust comes with a very basic thought process that there is no source, no identity that can be trusted directly. It could be inside your network, outside your network, or coming in from anywhere. We cannot trust it. They have to make sure they identify themselves well, followed by the system makes sure that the least access is provided to them on whatever they want to access, unless until they prove that they really require the access by itself. Right? The basic concept behind Zero Trust is I don't trust anyone. You prove, then you go inside. Why has Zero Trust really come into existence now? Right? You can see there are a plethora of applications that are there, SaaS applications, local applications. There have become plenty. Every company has got 15, 20 or more applications that are there, especially with the advent of SaaS products. The identity of a person is always in question, since a lot of people are working from the homes, logging in from different places. Identity is always a question, and there needs to be enough proof that the person actually is whom he says he is. The number of devices the people are using have tremendously increased. Multiple laptops, mobiles, tabs, and the identity is the same, but from place from where he's actually accessing changes drastically nowadays. You also see devices are not friendly as what it used to be before. A lot of software running could be very dangerous for what the network is, or what the systems inside a particular network is. Similarly, you have a lot of data that actually keeps coming in and going out. So we have to make sure data is not lost unnecessarily, or data doesn't come into the system unnecessarily. So this is where zero trust actually came into existence. Here, zero trust actually started implementing a lot of technologies, a lot of methodologies, wherein these systems can be easily monitored, managed, and audited. So starting on what is actually the need of remote access, right? There are a lot of reasons nowadays. It could be collaboration. It could be people working from home and requesting access for their own systems that are sitting inside a secure network. Of course, the major use cases usually IT support. They're supporting third-party vendors or suppliers coming into your network to do some changes, or the support is actually taking access of your desktop or device to check any problem. Of course, there is always productivity issues which are there, which can be resolved with a lot of remote access systems too. But of course, major reason why remote access typically happens is people are working from homes, or it could be an IT support that is actually looking at. Now, a lot of traditional softwares are available for remote access, but how are they used? What are the problems they have? Right? Most of the softwares are typically a VPN-based software, which itself is extremely vulnerable. There are a lot of problems with it. There are agents that needs to be deployed. Once the VPN access actually is given, horizontal access after the person lands into your network is a major threat, because you don't know what they're doing, where they're doing. Policy compliances are very difficult when people actually enter your network. They could be using compromised hardware. The software they're using to access your systems could be compromised. We are sometimes not sure of the identity by itself. We're not sure who's actually asking for remote access just by the username and passwords. And of course, there's another major problem, that any changes that they are doing inside your network, you have no idea what it is. There are no audits available. And getting all of these done on a single framework is also very, very difficult. That is where zero trust, or zero trust framework, as it is popularly known, actually kicked in. Right? Zero trust framework was a very beautiful framework, was actually given by a NIST. I would display that part of it for you. So wherein they actually described what zero trust framework really is about. It's got a control plane, which is actually a policy engine. This policy engine takes care of making sure who is coming into your network, what is he got access to, is the person and who he's claiming really the person he is, right? It also takes inputs from a lot of other devices, right? A lot of other systems. It could be your compliance systems. It could be a threat management systems. It could be activity logs of the devices. It could be an identity management. It's as simple as AD or ADFS or a radius that access kind of system. It could be any of the systems which is actually governing the policies of how a person needs to be accessing his own network, his own devices, other devices, or other applications. So once the policy engine gives a thumbs up saying that, okay, this is somebody who I know, and he's got rights to access these set of devices. It looks like his laptop can be trusted now. He can be trusted now, and what are the devices and applications which is being already given to him is also well known. The person is allowed to become from an untrusted person to a trusted person, and he enters the enterprise resources. Of course, even after entering, he's not left alone. We always make sure it's whatever he's doing is audited, and if there is something that he's not supposed to do, or he's trying something he isn't supposed to be doing, the system actually breaks his connections and asks him to get out of the network. So this is a very simple framework was actually devised by NIST. This is a framework which typically is being followed by most of the people. Even if you look at how Gartner has defined zero trust, they have typically spoken about a gateway system being available. The gateway system takes care of taking the request and then allowing a person inside. So the gateway could be on the cloud, it could be on premises. There are different models in which they are there. So it could be a network engineer, a server engineer, an outsourced engineer, your own set of team members, say your CEO or whoever, who is actually trying to access an application, or he's trying to access a specific device, or he's trying to access a server that is actually in your secure network. He can be accessing it via his own app, or he can be accessing it purely on a web. It actually comes into a policy engine. The policy engine checks with Radius, AD, LDAP, so basically an identity system, which actually identifies who is. It also has got additional things like two-factor authentications, multi-factor authentication, or whatever the company decides to check. It also has intelligent systems wherein it's checking where the location of the person is coming. The mobile, where is it sitting? A lot of different parameters are checked. Then once the identity is established, the system actually will ask for what are you actually trying to log into. Is it a server? Okay, is this server actually compromised, or is this server available for being remote accessed? Even if the server is available for remote access, is the server, how much of access can be given to this particular person who's actually getting in? Right? So all these parameters are defined. All the compliances need to be looked at. So compliance in terms of what changes they are doing, why they are doing this thing. Is it an approved change, is it an unapproved change? All these compliances are looked upon, and then finally, the gateway system actually gives access to the particular persons, right? And when the access is given, it actually starts a recording. The recording actually looks at what are you actually doing? Why are you doing it? Are you doing something which you're not supposed to see? So the recording system not only just records, it also even makes sure that you're not doing any policies, you're not violating any policies by itself. Right? So this way, your entire access becomes very, very secure because you're well authenticated, your devices are authenticated, the system you're actually touching actually also gets authenticated before you even have the capability to enter the network. Now, an obvious question comes in that once he's inside the network, he would be able to move around. No, but that's something not possible at all, because any device you're accessing has to go through the policy engine, has to go through the service gateway, right? Without going through them, you would not be able to access any other devices in the network. So it's extremely secure. You can't go from device to device. You can't go from network to network. All those things can be very, very easily restricted because the gateway is a single source of truth, and the gateway actually blocks you from doing anything. This way, the secure gateway actually acts as a big deterrent for any wrong activities that a person can actually do. You see, very secure system can be easily established with a zero trust network, a zero trust remote access system. What are the other complementing use cases? Of course, replacing VPNs is something that's very big and very, very highly asked. Privileged access management, you can implement SSO kind of systems wherein the username passwords are not even exposed to the particular person. Support, of course, support for third-party vendors. Recording of all the activities, remote working and working from home are also the big use cases of zero trust for remote access. I hope this was useful. Thank you so much.